Aloha, welcome to our video on temperature controls. In this video, we'll analyze how the heating of land, water, geographic position, altitude, and cloud cover all influence temperature. We'll define what an isotherm is, and we'll compare the heating of land and water. Okay, so if we look at the Earth as a whole and then we start looking at its pieces and parts, we'll notice that this temperature variation occurs. So different parts of the Earth are going to be at different temperatures than other parts. And there are several different reasons for this. One of the primary ones is going to be this difference between land and water. If you notice, if you go to the beach in the morning time, the sand is cold and the water is going to be kind of warm. If you stay there all day, when the sun comes out, the sand heats up faster and gets really hot, and the water now appears to be cool, even though it might be the same temperature. What we notice is that land is going to change temperatures quickly. Okay, it's going to heat up faster than our surrounding water. So the water is going to take longer, and that's because water has a higher specific heat. So if I'm an island surrounded by water, then I kind of have this buffering system that's going to keep the temperature about constant, versus if I'm in the middle of a continent surrounded by land, we're going to see greater fluctuations in daily temperature. Now, geographic position also plays a role, and primarily it's going to be how far are we from the equator. We're going to be warmer closer to the equator because we're going to average more daylight per year than we would if we were up at the poles. Okay, so we're going to see a little bit of difference that way. Altitude also plays a factor. Remember, we talked how we live in the troposphere, and the higher our altitude, the cooler the air temperatures are going to be. So that's going to make temperatures a little bit cooler that way. We also have this cloud cover or albedo, and what that's going to talk about is if we have clouds over us, the albedo is this reflection of the light off. So we basically don't get the energy coming inside, so it's going to be cooler during the daytime, but also it's going to trap this heat trying to get away so it doesn't get cooler at night. So when we have cloudy days, our temperature tends to be a little bit more constant than it is if we have clear skies, where during the daytime we'll get a whole bunch of sun and heating us up, but at nighttime we lose a lot of energy during a clear night. And then finally, we talked a little bit about currents, and if we bring warm water up, then what are we doing? We're heating everything up. And remember, water is going to work as a buffer. And the same is true if we bring cool water in as well. It'll be a little bit cooler that way. So we have a lot of different reasons why temperatures can vary. And in the lesson, it'll go over these in a little more detail. I just wanted to give you a quick overview. So let's take a quick look at this map of global temperatures in July. Now we have a little word here called isothermal. Iso is the same, thermal refers to temperature. So what this is going to show me is all of these different colors are going to be about the same temperature. So at the line here, everywhere on this line that you see that I drew a little bit of, it's going to be 20 degrees centigrade. A little bit above it to the north, notice we have a 10 degrees centigrade. So in between, we're going to have the 11s through 19s. And then we'll notice the same as if we go down, we can see that we're going to have the 21s through the 24s going to the 25 isothermal line. So isothermy is the same line, and we can kind of see, and we understand this one. We notice that we have the equator, which is going to run roughly right in through here. And this is going to be what we notice as the warmer part, because that's where it's getting the most sunlight, as the equator would be. And the further we go up or down, north or south from the equator, we're going to see a variation. Now, this being July means it's summertime in the northern hemisphere, so we're going to expect it to be warmer, and we can see that as we go up. Notice we have very little zeros here. We have a bunch of 5s, 15s. But if we go to the south, where it's their wintertime, we can see that there's a broader area of 0s and 5s, and then we even get some -10s and -20s because it's wintertime there. So we can see this fluctuation from the seasons as well. Okay, so that's it for this video. As always, good luck on your quiz, and we'll see you in the next video.